In this lesson, we're going to be looking at the mechanical advantage of a wedge. A wedge and an inclined plane are in some ways the same, but in some ways different. We're still using the same formula that we did before. The formula for IMA is still length divided by height. The question is, on the wedge, which one's length and which one's height, because length would usually be horizontal and height would usually be vertical, but not necessarily. In the length, you're always looking at the diagonal of the wedge. IMA is L over H, and the L is not necessarily horizontal, it's vertical. It's always on the diagonal of the wedge shape, and the H is always the perpendicular part that goes towards the point. I hope you see what I'm talking about here. So this thing could be turned around sideways, or it could be pointing straight up or straight down. You'd still have to know this will always be L here, this will always be H. Another point about the wedge is there's a big argument in engineering and science that whether or not the wedge length, the true length of this line, should be calculated. Some people think it should, and some people think it's so small a difference that it doesn't make a huge difference in the mechanical advantage calculations. In our class, we use the perpendicular distance of the wedge. Now you can notice that most wedges are in inches or small increments. The inclined plane, however, has feet. So we have to use the measurements for the inclined plane of the angle, but the measurements for the wedge will be perpendicular to the height. Okay, so with that said, now we've got to calculate how do we do this mechanical advantage. Well, we know we have a 10-inch length, and we know we have a 2.5-inch height on this particular wedge. So we just simply calculate what's in here. We say equals, and we come over here and say 10 inches. Let's say inches with the inch mark is too big. Let's just leave that out. And over 2.5. And then that equals. There, I got it. I straightened everything out. So IMA is L over H equals DE over DR, or the length is 10 inches divided by 2.5 inches, and the answer comes out to 4. It's not 4 inches. The inches factor out. So it's a 4-to-1 mechanical advantage ratio. Okay, so IMA is that. Now we can add some forces to our wedge and determine the AMA. So we're going to do some calculations. Let's pretend that we've got a hammer and we're driving a wedge into a piece of wood. And the force of effort that we're putting on the hammer is 30 pounds of force. So we're driving it up and driving the wedge into a piece of wood. So we've got F of E is 30 pounds. We've got a D of E from our IMA equation of 10 inches. We don't have F of R, but we have a D of R of 2.5 inches that we got from IMA as well. So we'll use those figures to calculate the D. So we set up our formula: 30 pounds times 10 inches equals F of R times 2.5 inches. So we do our calculations and we come out with F of R equals 120. 30 pounds times 10 divided by 2.5 is 120 pounds. The only unit that we have left standing is pounds right here. So that's how you would calculate that. Then you would feed that information into the top AMA. So we end up saying 120 pounds, which is what we found our calculation to be, divided by 30 pounds is equal to 4, a 4-to-1 ratio because our pounds factor out. So AMA is 4-to-1. IMA is 4-to-1. So our efficiency of this wedge is 1. So we're in equilibrium. It took us 30 pounds to create 120 pounds of overcome 120